Okay, welcome back. We are going to do 6.9, which is called finding the value of a relationship. And this is called solidifying understanding, which basically means we're still learning and we are not at the point where we can like basically practice. But by the end of today, you should be at the point where you're pretty solid. So today you'll be able to solve for the missing side and angle measures in a right triangle. And here's some questions you'll be able to answer. Well, we can find the missing side lengths and angles in a right triangle if two sides or two angles are known using the Pythagorean theorem, which is, leg squared plus leg squared equals hypotenuse squared, or the angle sum theorem, which is, remember that in a triangle, all angles will add up to 180 degrees. All angles in a triangle add up to 180, right? What information do we need to know to find the missing measures in a right triangle now that trig ratios are available as a computational tool? So basically, how can we use trig to further this knowledge beyond Pythagorean theorem, beyond triangle sum theorem? So how do we use trig to make indirect measurements when the object can't be measured directly? Okay, so it says pick a side. So Andrea and Bonita are resting under their favorite tree before hiking up a nature walk up a hill. Before taking a nature walk up a hill. Both girls have been studying trig in school, and now it seems like they see right triangles everywhere. For example, Andrea notices that the length of the shadow of a tree they are sitting under and wonders if they can calculate the height of a tree just by measuring the length of a shadow. Bonita thinks that they also need to know the measure of an angle, so she checks an app on her phone and finds that the angle of elevation of the sun at the current location and time of day is 50 degrees. In the meantime, Andrea has paced off the length of a tree's shadow and finds that it is 40 feet long. So just so that we're on the same page in terms of showing you what an angle of elevation is, I'm gonna look at, hold on, let me find it. One of the slides in your Desmos, right? And so I'm on slide 20, and this is the angle of elevation. So if you're here, right, and you're looking up, so you see how you're looking up, this is pretending like your line of sight, and you're looking at someone up there, right? So this little angle here is called your angle of elevation. So the angle of elevation is horizontal and up. Okay, a good way that I can measure or make you think about angle of elevation would be like if you were in the theater, like watching the movies, right? And you're sitting kind of like in the middle of the theater, middle row, middle seat. You're almost like looking straight ahead, right? But let's say you're sitting at the very, very front row of that movie theater. Now your angle of elevation is greater because now you're like having to crank your neck all the way up just so you can see the movie screen. Okay. So this is what angle of elevation is. Okay. So from horizontal to up. Okay. So then it says, so how might Andrea and Bonita use this information along with their knowledge of trig ratios to calculate the height of the tree? Andrea and Bonita know they can find the value of any trig ratio they might need for any acute angle using a calculator. Okay. So a couple of things here is we need always for these ones, draw a picture. And so I'm going to read a couple pieces of information in case you lost it. It says the shadow is 40 feet long and the angle of elevation is 50 degrees. And they want to know the height of the tree. So I'm going to draw a little picture. So I don't know, maybe this is what my picture kind of looks like. So here's their tree. I know, it's a great tree, right? And the sun's over here, right? And it's, right? And then you have the shadow that's like this or something. I don't know. Maybe that's too long of a shadow, but now let's make that shadow a little shorter. Sorry. Okay, something like that. Okay, and cast it there. So what you're going to do is you're going to draw, I don't know if you see the triangle, but I'm going to make the triangle very obvious to you. So the sun is like casting like kind of like this, like here, I'll draw like this, it's like this. You see this? Sorry, this is not a very good picture, but that's okay. And its shadow, let's make it just a little bit longer just so I can get that to hit. So does everybody see my angle of elevation? So this is my angle of elevation. So which they said was 50 degrees. Okay. So if you can't see my triangle, it looks kind of like this. Oops. There you go. Can you see that triangle there? So again, this is a right angle. They said this was 40 feet. Oops. And they want to know this height here. Okay. So your job is to figure out like how to do that. And so I'm going to hint you off. Number one, whenever you have a right triangle, you have a couple tools available to you. In here, it said you have the Pythagorean theorem, your triangle angle sum theorem, and trig ratio. So those are your three tools that you're going to use. So can you use the Pythagorean theorem here? And you're like, no, because I don't know enough of the sides to find that third side. So then you say, well, I'm not really looking for an angle, so I don't need the triangle angle sum theorem. So I must be using trig. So which trig ratio is this? Which trig ratio is this? Right? So I want you to think of sine of 50, cosine of 50, or tangent of 50. And which one of these is going to give me an equation based on what they gave me? Notice they gave me this side and this side. So could it be sine? And no, it can't be sine because sine is opposite over hypotenuse. And hypotenuse, I don't know it. And they didn't give it to me and I don't need to find it. So that's going to be a no. Same thing goes with cosine, which is adjacent over hypotenuse. Again, we don't know it and they don't want to tell us. So it must be tangent. Tangent is toa, which means opposite over adjacent. So this is going to be my winner because that's the opposite and that's the 40 feet is the adjacent, right? So I'm going to write my equation. It's tangent of 50 degrees equals to opposite, which is h, over 40 feet. And then how do you solve for that? Well, I'd multiply both sides by 40 because I'm dividing by 40 and that's how you undo it. So I go h is equal to 40 tangent of 50 degrees, which then I pull up my handy dandy Desmos. So 40 tangent of 50. Miss Johnson, don't forget to check if it's in, oh, it wasn't. So degree mode. So that's about 47.67 degrees. 47.67 degrees, right? So then, hold on a second. So then when you have that, so h, oops. So that means my tree is, even though this picture is not drawn to scale, just know, is 47 feet. Okay, so there's my answer for that. Put this in a little box. Okay, so and then figure out what part might have snagged you. Was it drawing a picture? I'm going to tell you right now. Imagine that I didn't draw this picture. Would you be able to find it? Most likely at this stage, no. Okay, at this stage in the game, you're still learning how to imagine what these pictures look like. So that's why I expect you guys to draw your pictures. Okay. All right, let's continue. It says, after their rest, and Andrea and Bonita are going for a walk straight up the side of the hill. Andrea decided to stretch before heading up the hill, while Bonita thought this would be a great time to get a head start. Once Bonita was 100 feet from Andrea, she stopped to take a break and looked at her GPS device and told her that she had walked 100 feet and had already increased her elevation by 40 feet. With a bit of time to waste, Bonita wrote down the trig ratios for angle A and angle B. So here they're very kind. They drew you a picture. And they want you to write out the trig ratios using angle A and angle B given these two sides, right? So here again, if you're not unsure, then I always go like this: sine, cosine, and tangent. And then I figure out which one is useful to me. So let's see. For sine, they gave me the opposite and they gave me the hypotenuse. They gave me the opposite and the hypotenuse. Which one of these three is the opposite and the hypotenuse? And it is sine, because sine is opposite over hypotenuse, which in this case is 40 feet over 100 feet. You can simplify this to, 2/5, right? So sine of A equals 2/5. So there's sine of A. So now you would have to figure out for B, I would do the same thing. Which sides did they give me in terms of B that relate to B? And so you go through sine of B and you're like, they didn't give me opposite. What about cosine? And you say, oh yeah, they gave me cosine. So they gave me the adjacent side and the hypotenuse side. So cosine of B is adjacent over hypotenuse, which in this case is 40 over 100, and that's 2/5. And you're like, oh, this is the same. Remember we talked about the switching the last time in the last lesson? Very good. So this guy's sine is equal to that guy's cosine. Okay. So if you're still getting used to thinking about sine, cosine, and tangent for an angle, just again, go over and over and over again, okay? So when Andrea caught up, she said, what about the unknown angle measures? When I was at the bottom and looked up to see you, I was thinking about an upward angle from me to you. But based on your picture, this would be angle A. Bonita wrote up the trigonometric sign, sine of A equals to 2/5, and said, so how do we find angle A? So if you notice here in this equation, sine A equals to 2/5, there's a variable, but you haven't quite learned how to find it. So together the girls talked about this talked about how this was like going backwards. And in math, we do this all the time. We teach you adding and then subtracting, multiplying, dividing, so on and so forth. So you learned about sine. How would you go backwards of sine? Instead of knowing the angle and using their calculators to find the ratio, like they did while working on the height of the tree, they now know the trig ratio and need to find an angle, an unknown angle. Bonita notices sine inverse of theta button on her calculator and wonders if this might work like the inverse trig ratio button, undoing the ratio to produce the angle. She decides to try it out and gets the following on her calculator. So by the way, if you're using Desmos, sine inverse is right there at the top middle column. Do you see that sine to the negative first? That's what they're talking about. So they say sine inverse. Now we're just going to plug it in. Sine inverse of 2/5. And see, we got 23.57, and it's in degree mode, so it's degrees. So basically they're saying if this is the case, then A must be 23 degrees, about 23.578 degrees. Okay, that's what they're saying. How might this output convince Bonita that her assumption about the calculator was true? And you can, I would like you to figure out like how would you convince Bonita that this was correct? Okay, so use the trig ratio you found for cosine b to find the value of b. So we're going back to this equation over here. Cosine b equals 2/5. We're going here. Cosine b equals to 2/5. So the way I ask it is, how do I get b out of cosine? How do I get b out of cosine? And the way we do that is we take the cosine of both sides. And I just scoot everybody over so I have room to write cosine inverse. Cosine inverse. So these two will cancel and pop your b out. Okay, they undo each other, like adding and subtracting, multiplying, dividing, squaring, square rooting. They undo each other. Okay, so you're left with b equals cosine inverse of 2/5. And that's what we're going to plug in here. So cosine inverse is right there. 2 divided by 5. Oops, not 25. 2 divided by 5 is 66.42. So B is about 66.42. Now I use about because it's not equal to, otherwise I'd have to grab all these decimals and the rest of them that the calculator didn't even show. So one more time, I'm going to say this again. When you have your variable and it's you're taking the cosine of it and you need to undo cosine, you use cosine inverse to find out what angle that is. Okay. So here you have to find all the unknown values for the given right triangle. So what are they talking about here? So what you're going to do is you are going to look at angle alpha and you have to find a way to figure out alpha's like what calculation would you use in order to find out angle alpha. Okay. And okay. Give me 1 second. Okay, so what you needed to do first is look at what numbers they gave you, and they only gave you A is 12. So I'm going to write 12 here. They gave you B is 8, and they gave you this guy is 90 degrees, which you kind of already knew. So if I told you to, and then they say these words, solve the triangle, how would you do? What would you do first? So I'm going to remind you of a couple of rules. So whenever I have right triangles, here are the tools. Number 1, Pythagorean theorem. And then number 2, trig ratios. Okay. So go ahead and find those, and then we'll be back to check your answers. I will give you a hint. You will have to use both of these in order to solve all of these.